is part D, I believe. Okay. So sine pi is up here, and excuse me, down here, and so sine pi is 0. So we end up with just simply pi. So determine the points. So at input of pi, output of pi, we have a horizontal tangent line. This is our exact value. If we wanted to come up with an approximate value, of course we could. Okay, well, let's go on to our next problem. This one is going to be practicing some of the same things we have been. First of all, for part A, we're going to find an equation of the tangent line at a specific point. So let's begin that piece of it. We're going to have to find the derivative of h with respect to t by finding the derivative of sine t. Remember, we just have looked at that. It's cosine t. And then the derivative of 1/2 e to the t. And remember, that's 1/2 e to the t. It's its own derivative. We want to know the equation of the tangent at that point. To find the equation of a line, we need to know the slope, and we need to know a point. Now, we obviously know a point, we're given that, but we need to find the slope at that point. So we're going to find the derivative of h at pi. So we have cosine pi plus 1/2 e to the pi quantity. We know that cosine, we were just looking at the unit circle, cosine at pi is -1, it'd be over here. So we end up then with -1 plus 1/2 e to the pi. Now, that's an exact value. If we were trying to write an equation of a line, we can use the exact value, or we would, on the Inspire, come up with an approximate. Let's go ahead and find the exact, or use the exact one. Remember, this is our slope of the tangent. So, to find the equation of the tangent line, we're going to have y equals, and we're going to have our slope, so that's -1 plus 1/2 e to the pi. Our slope times x minus our point, so it would be x minus pi. That's the input of the pi, plus 1/2 e to the pi is our output value of that. Now again, just keep in mind what we have here. This again is our slope, and these two pieces right here comprise our point of tangency. Okay, that's an adequate answer. We can do some algebra on this, though, and we can come up with y is equal to -1 plus 1/2 e to the pi times x. Let's see, this would be positive pi, take -1 times pi, plus pi divided by 2 e to the pi. So I'm just distributing pi across here. So negative pi times -1 would be positive pi, and negative pi times 1/2 e to the pi. I guess I need to change that sign, so we'll change that right now to be negative. Plus 1/2 e to the pi. It doesn't look really pretty, but if you think about it, all of this is the same thing as your output intercept. Okay, now if we look at this and verify, because this is a good one to verify, to graph that in the tangent point. So let's go ahead and look at this on the Inspire. Let's pick up a another graph, and remember that our function is the sine. And we're going to put sine x because in the graph where we can only use x as our input, but sine x plus, I'm just going to go ahead and build it as we see it, though we could have used 0.5 for that. And then e, it's right down there, e to the x power. So let's go back and make sure we've got that correct. We're going to say f1 of x, so it'll be sine x plus 1/2 e to the x. So sine x plus 1/2 e to the x. And that is our graph. Now we're wanting to look at a tangent at this point. So we're going to go ahead and let's place a point on the curve. Again, I'm not going to worry about where that point is just yet, because I'm going to change that input. Now, do not put in 3.14. Don't put in a decimal approximation. Go down here and actually put in the value pi. It's okay to do that, because once we hit enter, press enter, it will convert it, and it'll convert it to a much more exact or approximate, closer approximate value than you could put in. And whoops, what happened to our point? Well, obviously our point is above where we see it, so we can either graph, use another window, or we can just grab a hold of that and drag it down so that we can actually see that curve there. Okay, we need to put a point. Actually, we have a point. Let's put a tangent on that curve, and then we're interested in the equation of that. So menu, actions, coordinates, and equations, and let's just point. Let me try that again. Menu, actions, coordinates, and equations, and point to that. And that's the equation that we come up with, which doesn't really help us much since we have all of this. So what we need to do is to now find the equation of the tangent in an approximate. And again, let me write this down. This is an exact answer. But we need to, in order to check our work, we need to find an approximate answer. So let's look at how we can find whether or not our answer is equivalent. If we go back, there's our calculator page. I'm going to look at. Okay, let's check our work here. We can go to menu and go to calculus, and we can do the derivative with respect to x of, and we are actually using, let's see, f4 of x in this example. So I'm going to type in f4 of x. You can go ahead and retype the entire function if you wish. And so we get cosine x plus e to the x divided by 2. Is that what we got? And it is. Cosine t plus 1/2 e to the t is equivalent. We can also then, if we go to menu and calculus, we haven't looked at this, derivative at a point. But let's do that, and we want this to be at the value pi, and then we need to put in our function again, so that's f4 of x, and so the value would be e to the pi divided by 2 minus 1, e to the pi divided by 2 minus 1, so that is our exact answer. Let's get an approximate answer of that, and there's our approximate answer, 10.5703. So our work over here then, this is the exact answer, and then the approximate is about 10.57. So we can put that in now. Approximate 10.57. Okay. We want the equation of a line. Now, let's think about how we can use our inspires to help us here. The slope is here. Okay, so this is our slope. And our slope is the derivative at the point pi. Well, this is what we have here. So if we go up here and pick up this value times x. Actually, let's do this. It's the slope times x minus the input at our point, which is pi, plus the output of our point, which is 1/2 e to the pi. So we can either do that, or we could say f4 of pi. Because if we put pi in, we should get the 1/2 e to the pi. And we press enter. This now is the equivalent, the approximate value of our line. So 10.57x minus 21.64. Now let's see if by chance that is the graph that we had here. So here's our graph, and sure enough, 10.57x minus 21.64. Okay, so let's go back and look at this. Find the equation for the function, find the equation of the tangent line. We're not doing anything different than what we have been. We are looking at finding the derivative, determining the value of the derivative at a point, and then building the equation of our line.